Hi there, thank you so much for joining us today. Charlotte and I will be doing 3 experiments today that have to do with the surface of water. The first experiment that we'll be doing has to do with light refraction. And to do this, you just need 2 materials.
You need an ordinary straw and an ordinary glass of water.
That's right, that's all you need. So what we're going to do this experiment is to place this straight straw into the water. Watch what happens. Charlotte, can you please tell people what you observe?
I think it's getting a little bit thicker, kind of breaking apart there.
That's right. As you can see, the water has a magnifying effect on the object, depending upon the angle at which you're looking. And it also makes it look as if the object is breaking apart. And this is called light refraction. And so whenever an object passes through one material to another, in this case from air into water, it looks as if it's breaking apart. And also the water makes an object look bigger. And you can also observe this whenever you have toys in the bathtub. They can look bigger underwater depending upon the angle that you're looking at them from. And so that is light refraction. And light usually travels in a straight line, but it bends whenever it's passing from one substance to another. And that is refraction. Now the next experiment that we'll be doing
It's going to be about pennies.
that's right, and about surface tension. Now, water forms surface tension, or like a skin over it, and that's called the meniscus. That skin is called the meniscus. And so we're going to see today how the meniscus can stretch over the surface of the water. So here, all you need for this experiment are
a glass of water that's already filled, and then some pennies.
That's right. And this glass here is filled almost to the very top, as you can see. And so Charlotte is going to put pennies into the glass one by one, and we're going to see how many pennies it takes for the meniscus to stretch and finally spill over to the top. You might be surprised. It takes quite a few pennies. We did this experiment before, and in that case it took about 50 pennies for it to finally spill over. So we're going to see if it takes that many this time. And as Charlotte puts the pennies into the glass, without the water spilling over, I'm going to move the camera to show you how the meniscus stretches.
How come?
Let's see. You can see here? Do you see on the top of the glass there how the surface is stretching over? And you'd be surprised, the surface of water can stretch quite a bit before it finally spills over.
Oh, just spilled.
It's spilling over. There you go. Excellent. So that's surface tension. Excellent. Thank you, Charlotte. And so the third experiment that we'll be doing has to do with surface tension as well, and I like to call it the pepper pusher experiment. So Charlotte, as we prepare to do this, we'll get an ordinary bowl filled with water and some pepper. It doesn't matter what brand you use, just some regular household pepper. And Charlotte is going to fill the surface of the water with pepper. And we'll see what happens. And we're also going to need some dish soap for this experiment. And again, it doesn't matter what brand. So Charlotte, as you can see, this bowl is filled with pepper. And Charlotte, would you please put your finger in there? What happens? Not much happens, right? You just have some pepper water on your finger, but nothing really happened to the pepper water in the bowl. It just pretty much stayed the same. And so now we're going to try this with Charlotte putting some soap on the finger. Let's see what happens to the pepper in the water. Ready? Whoa! What happened?
It's separated.
It's separated, that's right. The pepper moved to the sides and the bottom of the bowl. Would you try it again, please, Charlotte? Yeah. That's right. See, it's making little breaks in the surface of the water there. And that's partly how soap works, because it breaks apart the materials.
That's like what your dishes do.
That's right, whenever you wash your dishes. That's how soap helps to clean your dishes. And so what happened was the pepper was floating on the water's meniscus, and that was created by surface tension. And whenever Charlotte put her clean finger into the water, the surface tension remained intact. But soap can break the water's surface tension. And so whenever her soapy finger entered the water, the surface tension was broken and the pepper was pushed to the edge and the bottom of the bowl. And we'll try that experiment one more time just to show how it happens. So here you go. Charlotte's going to clean her fingers. Because remember that the real scientists replicate their experiments many times using similar conditions in order to ensure that they get accurate results. So here, put some more pepper in the bowl. There you go. Awesome, thank you. And so now Charlotte's going to put some soap on her finger. Thank you. We'll see how that happens. We'll demonstrate this for the camera. Here we go. Wow, look at that. It's breaking apart again. That happened because of the soap. So there you have it. There's surface tension. Thank you so much for joining us today.
Bye.